Yep, got it.
Yeah, so welcome on DataOps Poland Meetup. Today, how to avoid the data mess in data mesh. So, Andrea, stage is yours. I'm stop sharing the screen and your turn.
Okay. Tell me when you see the presentation so I can start. First of all, let me thank you for having me tonight, and also thank you all the people that have joined me to listen to the presentation live. The presentation, as you may know, because you have read the abstract, is mainly on data contract, especially explain how the data contract as what are data contract and why data contract are so important, specifically in the context of data mesh, as the title say, to avoid to create a data mesh instead of a data mesh. So the presentation is divided mainly in two parts. The first part is an introduction to data mesh. Probably you already know what is data mesh, but just to be sure that everybody is on the same page before to delve more into the concept of data contract and explain what is a data contract and why data contract is so important in the context of data mesh, how data contracts apply to the context of data mesh, and help to implement them in the right way, in a controlled way. Before to start, my name is Andrea Gioia. I am a partner, CTO in Quantica, that is a consultancy firm based in Italy, specialized in data and metadata management. I work in the data field for the last 20 years, so I have a bit of experience. In the last 5 years, I worked especially as a CTO of Quantica, helping customer in design and define their data strategy. So I'm really interested in, of course, in technology, new approach to data management, and in particular to the organizational side, because for what I've seen in the last 5 years, there's not a single project that has been failed because of the decision to take the wrong technology. The technology is quite good, especially if we see the leader of the market. Usually projects do not succeed because of the wrong organizational model. So this is why I'm so interested in data mesh, in the computational governance, in concepts that are technology related, but also organizational related, because these are two faces of the same coin. And if it is not well designed, also the organization, you can design on the board whatever kind of architecture, but probably you are going to fail and repeat the same problem that you have in the past. And so nothing change, and your data strategy continue to produce cost and are not evolvable over time. Say that, let's start. Before to give an introduction, explain what is a data mesh, let me just give a brief overview of how data management has been changing in the last, let me say, 10, 15 years, just to give an overview how we are arrived at this point, a data mesh, a new approach, and these paradigm shifts that are happening in the practice of data engineering. At the very beginning of the third industrial revolution, where companies started to digitalize their core processes, there were very few applications, large applications that digitalized the most important process of each company, and the analytics is performed usually directly within that application. And when sometime there was the need to integrate the data across different applications to do analytics or implement use cases, point-to-point integration is developed. This is not pictured in the slide, but it was really the beginning of the analytics world, an architecture composed by point-to-point integration between application implemented as a project, one-shot project, as the data should be moved for implemented use case from an application to another application. Of course, as soon as the number of applications start to increase, this model of implementing integration was not sustainable. Basically, the architecture is not an architecture, it's an incidental architecture, became a big mess, impossible to maintain. And so we started to develop data platform. The first type of data platform was the traditional data warehouse. So one place in which all the data that are generated into the company by the different application is collected, and then this data is cleaned and modeled in order to provide the right model for the different use cases. Possible the same data reused for multiple use cases. This centralized platform is usually managed by a central data team. Then the things are changed in the data management world. So the traditional data warehouse has been moved to a data lake, then a data lakehouse, then a cloud data platform. So we have different stages in the architecture, different technologies come in, and the architecture of the data platform changed. But basically, the overall idea, the conceptual architecture remained the same. We have a central platform managed by a central team that try to decouple as much as possible data producer for data consumer. The promise of this kind of centralized platform is to store all the company data in one place and use this data as an asset to implement multiple use cases, reducing the complexity that was unmanageable in a point-to-point spaghetti integration architecture. This promise is only partially maintained. Why? Because from one side, the number and the diversity of the application is constantly increasing year after year. And on the other side, the type of consumers also diversify and increase year over year. So at the beginning, the consumer of the data platform, of the analytical data platform, was basically only reporting. Now we have service BI, we have machine learning, artificial intelligence, different models. So there are different consumers, and we have a lot of applications that produce data. This translates in a big cognitive load that is pushed upon the central team that very, very fast became a bottleneck in this kind of organizational model. And so at this time, the central data team have basically two options. One option is to, as soon the complexity starts to increase because you have more data sources and you have more consumer, try to refactor every time the data platform in order to keep it clean, reduce the technical debt, and try to reuse whatever you have already created to adapt it in order to also respond to the new use cases and keep the platform and the development of the platform sustainable over time. Of course, these require to reduce the speed of delivery of the team as soon as the complexity around the platform increases. So you have to reduce the speed, to reduce the technical debt, and to keep the platform sustainable over time. Unfortunately, this option is usually not followed by the data team. The data team prefer the other option because I have more return in the short time. So when the demand from the business is pushing, instead to try to keep the platform clean, it's better to try to answer with the same velocity of the past. To do that, usually they inject into the platform some technical debt. They do some quick and dirt hack in order to respond faster to the demand of that come from the business, hoping to have time in the future to clean up this technical debt. This time never came, and the debt within the platform increased time over time, and the platform in a very short amount of time became basically unmanageable. So basically every time you have a new requirement, you basically add it to the platform without thinking if it is possible to refactor an existing module to fit also that requirement, because everything is interacting with everything. And so if something works, why modify this that can create a bigger problem in other part of the platform? Is better to create another part of the platform that satisfies the new use case. So the platform became very complex internally with a very duplication of data that is impossible from a cognitive load perspective. It's possible to keep and understand all the platform cannot fit in the mind of the data team. So usually the platform at some time became totally unmanageable, and so company decide to create a new data platform that stand aside the old one, hoping to be able to decommission the old one sometime later. At the beginning, the new platform is fantastic because you take the new technology, the best technology that is available at that moment on the market, and the development speed up a lot because the platform is empty. So you have very few data to manage. It's very simple to keep all the structure of the platform in the mind of the data team. There is not a very big cognitive load, but because the new technology is better than the previous one, you go more fast, but you apply the same old operating model. So more faster, you create more technical debt. At some time, also the new platforms start to have the same problem of the old one. And probably you find out that the old one is not possible to be decommissioned. So you have two platforms with the same problem. You have basically doubled up the problem that you have to manage. This is basically a trend that I see in a lot of customers that have 2, 3 generations of data platform that leave one aside the other. And so I can see the old data warehouse on Oracle, then there is a data lake on some cloud provider, and then there is Snowflake, everything living in the same ecosystem. So how we can rethink the data engineering practice to resolve this fundamental problem that is related to having this monolithic application managed by a central team that became easily a bottleneck. Basically, just applying a good engineering principle, nothing new. Do not create a monolith, but create a platform that is modular, that is a composition of different modules that talk to each other. If you still have a central data team, but you are designing a platform in a modular way, the cognitive load on the team is reduced because every time they need to do a modification, there is not true anymore that everything is correlated with everything, but they concentrate and switch to work on a specific product or group of products that interact through a very clear interfaces. So the complexity, the overall complexity is the same, but every time they need to work and do a modification, they can do a modification locally to the point in which they are modifying the thing to implement the new use cases, and they can forget about the other part of the platform that are not correlated. So it's more simple. It's basically based on a good engineer principle, a concept of interfaces, information hiding, interacting in different modules, and the isolation of each module. Then, when you have created a platform that is more modular in its architecture, you can also start to think that the central data team does not necessarily have to be owner of all these modules, but you can start to spread the ownership among the different modules that compose the data platform. For example, on other teams or teams that are more close to the source system that produce that data, or teams that are more close to the use case that will consume that enriched data. So, in one word, pushing the responsibility and the ownership of this module that are usually called data product more toward the domains that are in the first place within a company, the entity that generate and consume data, and leaving to the team, to the data team, only the responsibility to build the platform and provide the functionality to this other team to implement their data product in a simpler way. So this is the trend. This is the paradigm shift that took us where we are now to a more modular and decentralized approach to data management. Of course, in this context, because you have a lot of moving parts that compose your architecture, there is not only a big monolith. It's very important, as I already said, to define the interfaces and how all these parts interact. And this is where data product come in the discussion, because the data product basically are some kind of application, but in a different way from normal application. Their reason to exist is not to expose functionality, but is to expose data. So like a traditional software application describes its interface to an API, to a set of agreements that describe the service and the interface of the service, in the same way, the agreement that describe the interface of the data product are called usually data content. It is very important to not have not a modular platform, but a platform that is just a collection of silos that are not interoperable, and is very complex to put them together and compose a solution composing these different modules. Okay, so let's see the data mesh in particular. Of course, the data mesh is not only the only one new approach to data management that push toward the decentralization and the modularization of the platform, but for sure is the one that is more popular and the one that is that have more focus not only on the technological part but also on the organizational part. In general, all these approaches, data mesh is the most popular one, are called data-centric approach because are based on the concept that data must be a first citizen in the enterprise architecture. So we do not design architectures anymore around application, and then we do the integration of data generated by this application as an afterthought, so in a tactical way, but we design the architecture around the data, around the application, but also around the data, and probably first around the data, because in a complex organization, application come and goes. Consider that in a large enterprise, the average lifetime of an application is 3 to 4 years. Instead, the data generated by this application remain within the organization for decades. So basically, there is more value in the data generated by the application than in the application itself. So it's absolutely reasonable to design the overall architecture and decide your trade-off in the design of architecture, not favoring the application, but favoring the data architecture. So these approaches are data-centric for this reason, and all the data-centric approach are based on the concept of the pillar, on the principle of data product. Basically, modularize your application, all the modules are data product, and then we will see what a data product is. But for the moment, consider a data product as a modular part within your data architecture. From this, in the data mesh, derive other 3 key pillars, 3 principles that derive directly to do the first one, from my point of view, because if you want to create a platform that is modular, you have a different problem. And the other principle try to balance this problem, providing solution to reduce the other problem that come out from a solution that is not anymore centralized, a big monolith, a big central monolith, but is a composition of different data products. The first is what is called the Federated Computational Governance. Basically, here the idea is similar to what I said before about the data contract. If you have different modules in your platform, you must be sure that these modules are not silos that are unable to interoperate with the other modules, but can interoperate easily. So you need, I said you need to have data contract in place, but in reality, you need to have a lot of global policy that ensure that all the system can work properly together. And these policies are defined by the central federated team. The central governance federated team is a team composed by all the main stakeholders, basically the different product owner, the platform owner, other external stakeholders, and define the rule of the game. What are the characteristics? For example, if we are talking about a data contract, what is a data product, and how a data product expose its agreement, its interface to a data contract, what is the structure of the data contract that you are going to use within your company, and to which every data product team must comply, is something that is defined by the central federated team. Because in the central governance federated team, all the parties are represented. You have the guarantee that the policy that are defined can be a good fit for all the team and can satisfy all the interested part and can be sustainable in the long run. There is another word here that is computational. Computational is important because we want to define policy that can be machine readable in order to make it automatizable by the platform, in order to make their implementation more easy for the team that created the data product. So the policy defined by the central federated team should not be pieces of documentation, but should be policy defined as a code that can be then implemented or at least supported by the underlying platform in order to make the product team empowered and make for them easier to implement this policy without implementing from scratch all the stuff and the technical infrastructure that you need to put them in place and be compliant to the policy itself. Another pillar is the domain agnostic service data platform. I've already mentioned the existence of a platform. This is important because if I modularize my platform in a different model, in a different data product, I don't want that each module have to re-implement from scratch all the integration stack. Basically, that each data product is in itself a small data platform, because this is not sustainable in the long run. I have not enough engineering power to be sure that each data product have the knowledge and the person that are able to recreate all the technology stack. And this is also a way to waste money, because I have no sense. So I want to decentralize the implementation of the different data product or the different module, but I want to centralize from one side, so how I define the rule of the game, but also I want to centralize the platform that provide domain agnostic services in a self-service way, possibly, to the team that implement the data product. So the idea is to hide as much as possible the technological complexity of the underlying platform to this team, to the data product team, in order to make them focused on the implementation of the business logic, in order to be able to create this team without requiring to have an hardcore data engineer inside the team, because there is a lot of technology complexity to manage, but have something that is more composed by business people and business analysts, so to simplify the implementation of this data product and to rationalize the cost to implement the technological stuff, because I not spread it in a million data product, but I centralize and try to do economy of scale. So to provide the same service that are usable for multiple data products and are used by multiple teams. Last but not least, of course, the domain-oriented decentralization. So if I have different modules, I have just introduced this concept. I want also to spread the responsibility over these data products. So data mesh strongly push on the concept of decentralizing toward the business domain. So the data product must be in the data mesh owned by the business domain. Or because the business domain produced the data that is exposed by the data product, or because that particular business domain enrich the data to implement some specific use case. But most of all, because the domain know the semantic of the data, know what you want to do with the data, and so is a better fit to have the responsibility over the data product that manage and expose to the rest of the system that specific data. So let's briefly, in this introduction, and then we will move to the part related to the data content, take all these pillars and just say some more things related to this before to start to talk about data content. So the first thing is, okay, we have mentioned a data product. I have repeated this word a lot of time during the first slide, but what is exactly a data product? At least in the data mesh paradigm, what is a data product? Data product basically is the smallest unit of deployment in a mesh architecture. So a data product is not just a data set or a data that is produced, but is the data together with the application that generated that data, and together with the infrastructure that is used to run the application that generate the data, plus all the interfaces that clearly describe what is an internal and private part of the data product and what is instead accessible from the outside by the consumer of the product. Last but not least, so say that the data product contains all the components that are needed to deploy it in a production environment. So it's not only the data, but all the part. And last but not least, the data product must have a clear ownership. So it's not possible to have a data product that is shared, which development is shared among different teams, but there is a team, there is a clear owner of each data product. This is basically the data product. If you want to make a comparison, a data product is nothing so different from a microservice in the concept, but where the microservice is designed to provide a functionality in the first place, the aim of a data product is not to expose functionality to the outside world, but to expose data. But say that basically they are almost the same thing, because also the microservice is not only the API, it's also the database, it's also the application that implemented the services exposed, it's also the infrastructure. A microservice is something that can be deployed in atomic way, and the same thing is true for a data product in a data architecture. Then there is the concept of federated computational governance. Here, for me, it's very important that the federated team, as I said, define the rule of the game. And it's important to understand that in different organizations, the scope of the federated team, of the federated governance team can be different. Of course, in every situation in which you try to decentralize and modularize the architecture, the central federated team of governance must be in charge to define rules that are related to security, that are related to the operational level that must be guaranteed by each module, and the rule that guarantee that each module can interoperate. This scope, this is the minimum scope that characterized all the central federated governance team. Then there are teams that also have a bigger scope. For example, can define policy related to the infrastructure, so related to the software and application that must be used to implement the data product. There are teams that are also responsible for the way in which the data should be modeled. Teams that are also in charge to define the different processes or the operating model. So the scope can be very different, from the smallest possible one, the minimum scope that just guarantees security, interoperability, and operational level, from a very large scope that defines basically everything that is possible to define. Of course, when the scope of the governance is very wide, the data product team have a very small freedom, a very small space of movement, because the way in which they should model data, the application that they should use are all decided by the central federated team. But on the other hand, if they are really controlled in the way they work, they could also count on an underlying platform that can provide services, self-service services, at a very high level of abstraction. Because basically the architecture of the platform, the way in which data is modeled, the different technology used are known in advance because are defined by the governance team. And so the platform team can do a lot of high-level service to automatize all this part and to provide high-level service in a declarative way to the different data product team. Basically, they can build a fat platform, a data fabric that automatize a lot, and so keep away a lot of complexity from the team that developed the data product. Otherwise, if we have a very limited scope for the central team, the platform cannot provide this higher level service, but should be very, very lean and basically reduced just to a platform that provide storage and computational resources, because I said that all the other things are not defined, and different data product can pick different technology, can pick different modeling strategy. There are a lot of freedom, so there is not a lot of stuff solid and defined in advance on which the data platform team can build and provide service upon. So they provide very granular and low-level resources to the team. So the team have a lot of freedom, but have a less support to from the platform. They have to implement the stuff that they want to use. So they are free to do a lot of things, but they have to do by their own. So different customers are set in different position of the spectrum depending on how large is the scope of the data governance team. And we can move from one extreme, that is the fully governed mesh with a data fabric as a platform. And on the other side, we have a fully federated mesh in which the central team just defined the interoperability rule, security rule, and that's it. All the other aspects of how to implement a data product are leave to the product team that can do whatever they want. About the platform that you need to implement in order to facilitate the different data product, to implement the data product to be compliant with all the rules defined by the federated central governance team, are in a data mesh usually composed by different services that are grouped in three main planes. We have the utility plane, that is the plane that basically provides the very low level resources, so storage, compute, and try to abstract away from the underlying technology, so provide services that hide the complexity of the underlying technology and give the same service in a declarative way, in a simplified way to the consumer of the utility plane. On top, there is the control plane that provide all the services that are needed to manage the life cycle of a data product, from the development to creation, deployment, till arriving to the decommissioning. So it's very data product oriented and do the data ops basically around the data product, around the concept of data product, managing all its life cycle and automatizing as much as possible the management of the life cycle of single data product. And last but not least, we have the experience plane. The experience plane, basically, it's not focused on a single data product, but it's have a view on all the mesh, so all the data product, and basically work as a sort of control plane for the mesh, providing functionalities such as research, observability, the possibility to define global policy that must be followed by all the products. So it's basically something, it's like a sort of control plane over the mesh, or you can also see it as a marketplace over the products that are available in the mesh. It's the part that provides the services that are more close to the final consumer of the mesh, that need to acquire the data from the different data products to implement their final use cases. Last principle is the domain-oriented decentralized data ownership. Here, of course, the mesh is for a fully decentralization of the ownership. So basically, each product must belong in the ideal way of thinking of the mesh to a particular domain, and the ownership of the data product belong to that domain. Of course, this is not the situation in most of the customers, at least at the beginning. So at the beginning, all the customers have all the organization. Sorry, I say every time customer because I'm in a consultancy, but of course, all the organization, not all the organization are necessarily customer of a consultancy firm. But anyway, all the organizations start from a centralized team. I want to moving in incremental way to decentralized. So when you want to take this journey to moving toward the mesh and start to modularize your platform and decentralize the ownership, you have basically two possible options. One option is to starting from the decentralization of the ownership related to all the work upon data that are enriching, adding information, cleaning, creating models, so that are more close to the data product that are consumer aligned, that take the raw data and enrich the raw data in order to serve the different use cases. So some organizations keep centralized all the data product and the implementation of the part that is designed to acquire the raw data and land the data into the platform. So this remains a responsibility to the platform team, to the centralized data team, and instead decentralize the data product that are more related to enriching the data, to prepare the data for the use cases. So using the term of the data mesh, to that data product that are consumed aligned. Instead, the data product that are source aligned, so that ingest the raw data from the operational system remain a responsibility of the centralized team. Other organizations do the other way, so keep centralized all the parts that are related to create the product that are consumer-oriented, so that implement, for example, the unified model of the company and produce all the different enrichment that then can be used to implement the use case, and instead decentralize the acquisition of the raw data, usually because this company, the most common path is the first one, but I have seen also some organizations that follow the second one. Usually these are companies in the business information, so that acquire data from outside the boundary of the companies, from internet, from external data provider, or company that have a very complex source system. So there is a large knowledge related to how acquire data from a specific source. So it's a good idea to create a dedicated team for all these sources, because there is a lot of knowledge there, and it's more important how I acquire data, and then instead I can centralize how this data is modeled and produce the final result. Of course, this is not a black or white solution. There are also customers that keep everything centralized and just decentralize some product that can be hybrid. Some products are related to a very complex source system, source-aligned data product related to very complex source system, and some other products that are related, for example, to all the machine learning, because you already have in your topology, in your organizational topology, you already have a centralized data team. So all the data products that are implementing an AI or an ML model can be given to this particular team. So there are different options to start to decentralize the ownership. You cannot decentralize totally the ownership overnight from a totally centralized to a totally decentralized, because you need to decentralizing, of course, help in scaling, but also require to have a good data ops practice in place, because otherwise it became very soon a big chaos. So you can centralize it as much as you are able to implement and you are mature in your data ops practice. So because usually when you start and you have a centralized data team, you are not so good in data ops, because you do not need to do a lot of data ops if you have one only team. When you start to decentralize, you also start to become better in data ops, and the two things goes end by end. So you cannot decentralize from 0 to 100% decentralization, because you have not the time to implement this capability, this practice in data ops that are fundamental to sustain this kind of decentralization. Another thing that I want to say is that also is very important, that the fact that the total decentralization that the mesh theorize is not the landing point for all the company, because you want to decentralize to improve the scalability, but probably the scalability that you need can be reached even also a full decentralization. So if you reach the level of scalability of your platform that you need for your business, decentralizing even more the ownership have not the return of the investment that you expect. The return of the investment became marginal. So not for all the company arriving to a full decentralization is the end point. Some company can stop before, because they have reached through the decentralization that they have already implemented the level of scalability that they need in that particular moment of their evolution. Of course, then the thing can change, because the business can grow, you can have merger and acquisition. So what is true today can change tomorrow. But consider that fully decentralization is not necessarily good and perfect for everyone, because it comes with a cost. So you have every time calculate the return of the investment. And if you are happy with the scalability that you have reached, you have not to push for having even more decentralization. So just to close this part on the introduction of the data mesh and start to talk about the data contract, this is a slide that put everything together, basically give an image of the topology of team in a data mesh architecture. So this is more on the organizational side. As you see, I have the two circles that are the two kind of data products that I can develop in a data mesh. The one that are more source-oriented, that have the responsibility to acquire data from operational system and expose this data in a usable format to the rest of the organization. And on the right, the circle on the right, there are all the data products that are more consumer-oriented, so that enrich the data in order to make it usable for the different use cases. These products are owned by the source aligned, should be owned by the system that produced the data. Instead, the consumer aligned should be owned by the team that are going to implement the use case. So in general, as I said before, it should be pushed as much as possible toward the domains. On the top, we have the Federated Governance that its first mission is to enforce interoperability, define the rule of the game, but at minimum, define the policies, the global policy that ensure interoperability between the different data products, because otherwise data products are not data products, are just data silos. And but they're not going to implement these policies. They just defined them. The implementation of the policy is something that is a responsibility of each single data product team. On the bottom part, we have the mesh platform team that is responsible to make as easy as possible for the data product team to implement the data product and be compliant with the policy. And then we have other two teams that can be implemented or not, depending by the different situation, by the different data strategy that the organization want to implement. We have the enabling team. The enabling team is a team composed by resources skilled in the data mesh that know very well the practice and know very well the data platform, and can be used to collaborate with other teams, to onboard the team to the new paradigm, and then to implement their data product in order to do knowledge transfer. And this is very useful at the beginning of the data mesh adoption journey, because maybe the different teams have not already a strong knowledge of the platform, and not already a strong knowledge of the mesh principles. So they own the product, but having some person from the enabling team that work with them can be helpful to bootstrap and start to work in this new paradigm. And then the enabling team leave the data product team as soon this team has onboarded all the necessary knowledge to be autonomous in implementing and evolving their data products. In some situations, it's also useful to define a modeling team. A modeling team can be seen as a special part of the federated team that is in charge of defining the unified company model. Sometimes it's also useful to define how to model some entity that are core to the business, and make a rule that all the data product source-oriented that generate the data related to that entities or to the processes must be compliant with the model defined centrally, in order to facilitate even more the interoperability and not push this work of semantic normalization, semantic shift of the data that come from different data products that are source-oriented to the consumer-oriented data product, because this normalization must be done basically in each data product, if in each consumer-oriented data product, if I have not a central model that unify the semantic across the different sources. This unification must be done by each consumer-aligned data product. Instead, if I have a model, a standard model that is defined by the federated governance team or the modeling team, as you prefer to call it, in this case, this work of semantic shift is performed only in one place and is global to all the company. Of course, this modeling introduce a bottleneck, so you have to decide what is the better trade-off for you. If you want to have one big unified model, if you want to have more smaller model, if you don't want to have any central model and leave the responsibility to do the semantic shift between the data that are aligned with the sources to the data that are more aligned to the business and to the use cases, something that must be performed case by case by each consumer aligned data product. In all these cases, as I said, because the Federated Governance team first mission is to guarantee the interoperability between the team that develop the data product, one of their first mission is to define what is exactly a data product, and specifically how the data product can define formally its interfaces in order to be easily usable by other data products, and so at the end of the day guarantee this interoperability that is very, very important. The answer is data contract. Basically, so one of the first things is define what is a data product in general, and then specifically what is a data contract, that is the interface part of a data product. But let's repeat, what is a data contract? A data contract basically is a set of formal agreement between a data producer and its consumer about data generated and shared for production-grade use cases. A good data contract, so the ownership to define exactly the structure of the data contract belong to the data governance team, and then the implementation of the data contract, the definition, and then the implementation, the ownership on the data contract instead is on the data product team. A good data contract should have some characteristics. Of course, should be addressable, so should be really clear what data contract I'm talking about. So each data contract should have a unique identifier and should have a unique version. Of course, data contract can change over time, so it's an object that is versioned, and the sum of the unique name and the version is the fully qualified name of the data product, and I can use this unified resource identifier to address in an ambiguous way the data product. Then the data contract, sorry. Then each data contract must be scoped and expressive. So basically, should contain in a clear and unambiguous way all the information that are needed for the consumer to consume the data exposed by the data product. Here, I want to underline the fact that the definition of the data contract must be formal. So must be absolutely clear, not ambiguous. It's not a piece of documentation, something written in a natural language. Should be clear, exactly like an API for a microservice. Should be clear what is part of the interface, how I can access the different endpoint and get the data that I need that is exposed by the data product. Then a data contract should also be reasonable, stable over time. As I said, a data contract, of course, can change, have a life cycle. So the data exposure can change over time, and by consequence, also the data contract that describe that data, that interface that expose that data can change over time. And this is the reason why data contracts are versioned. But have no sense to define a contract on a piece of data that is used for development, for prototyping, that basically change very, very frequently, because implementing a data product and also guarantee that the product, defining and implementing a data contracts and guarantee that the contracts is respected is something that have a cost. So if you have to change it every day, basically have no sense to spend this cost. So basically data contracts are used for data that are quite stable, that are designed for production grade, exactly like an API. You do not want to define and document an API for a services that is in implementation mode, experimentation mode, prototyping, so can change basically every day, but you want to define an API for something that is stable and is going to use it for at least a couple of months before having a change that is not just a patch. So just to recap, a data product is not a data contract. A data contract is a part of the definition of the data product. In particular, a data product exposes interfaces through different ports according to the type of service exposed. So we have the control port that exposes all the functionality that can be called by the outside world to change the configuration and the behavior at the runtime of the data product. We have the input and output port that are used to collect the data used by the data product, and the output port that expose the services used, that provide the services used to expose the data produced by the data product. And then we have the discovery and the observability port. Discovery port are used to get the metadata that describe the data product, and the observability port, all the metrics related to the data product in its operation environment. All these services describe their interfaces to service agreement. The port that expose data, the service agreement that describe the interface of the port that expose data, so the output port, but also the observability port, because also observability data is basically data, is not a functionality, it's data that can be read from the outside world. So this can be think as a port that expose data. Basically, this agreement that describe the interfaces of this port are data contract. Data contract, by the way, is only part of the definition of that. Data contract is only a part of the whole definition of a data product. What a data product should contain? Basically, usually you start defining a data contract starting from the schema of the data that you are going to expose, promising that you will expose the data using that particular schema, and you are not going to change the schema without to change before the contract. More in general, the schema is a part of an API, so you can also not only expose in your contract the schema, but the full API. So I declare what is the schema, but also what is the endpoint that you can call to get the data exposed through that particular schema. Of course, you can have a lot of different type of APIs, and around there are a good standard to represent this API. For example, if the data is exposed to a REST API, like usually happen for the observability port, you can use to describe your API the OpenAPI standard. Instead, if your data is exposed by a streaming application, there is a good standard to describe API of streaming application that is async API. If it is just a table in a queryable database, you can use the data store API to describe your API. So there are standards available out there to describe the API, and weaving the API, the endpoint, and weaving the endpoint, the scheme of the data that is exposed by that particular endpoint. The endpoint can be a REST endpoint, can be a topic in your Kafka, can be a table in your database. According to this different situation, you have different standards to describe your API. But anyway, our standard with an ecosystem of tool and contributors, so you can leverage this kind of ecosystem if you are using a standard that are quite popular to describe this kind of API. Then there are the constraints. Constraint, basically, within a contract, explain what are the constraints about the data that you are exposing. So, for example, usually constraint refer, but not only, but usually the constraint refer to the schema. So specifying, for example, that one column is a key column, one column is a foreign key, one column is not nullable, or this kind of information that then can be used to check the validity of the data exposed, applying this constraint and verify if these constraints are respected about the actual data that your product is exposing. Usually, the constraints are translated in a data quality check implemented, for example, with Great Expectations, SODAR, or other kind of application that do data quality and check on data. And then, last but not least, there is the semantics. Semantics basically describe how a particular field, how a particular entity that you are exposing relate to a concept that is described in your business glossary or in your corporate knowledge graph. This is performed usually through tagging or for more complex and advanced implementation can be described through semantic linking. Semantic linking means create a link between the field or the entity and the specific object or concept in your business glossary or in your knowledge graph, in order to create a context to understand the semantic of the data that you are exposed. Adopting data contract is not an easy thing. It's really a challenge, like adopting data mesh, because both things have in common the fact that it's not only a technological challenge, but it's also a organizational challenge, because data contract at the end of the day are defined and enforced at a technological level. So the way you define the specification that you use to define your data contract and the platform that do the enforcing of the data contract is a technological problem. But data contracts are made, negotiated, and owned by person, by different team. So you have to change also the responsibility of the team, and you have also to change a little bit your organization and realign the incentive of the team in order to take care about the data contract that they made with other team. This is not an easy thing to do, because a lot of your team have not this responsibility before, and now they have a new things on their plate to do, and this is something that cannot be implemented, hoping that in a best effort, each team will work to create a data contract and respect data contract. You need to change the organization, the operating model, realigning the incentive, because otherwise every time the pushing from the business became very strong, the first thing that you cut off, if it is not aligned with your objective, is the fact to define and maintain and respect the data contract that you have made with other teams. So you need to do as a modification at the organizational level, and usually, from my experience, modifying the organization is one order or more of magnitude more complex than modify the technological architecture, because you have to work with people and politics and previous power that people have on people, and change things it's quite complex. Let's focus a little bit on both these side of the challenge, the technological one and the organizational one, and then I have finished and I leave you to any kind of question that you want to make me. From the technical side, what you need, as I said just before, you need to have a specification, because you do not want to have data contract defined in a formal way, but with different formalism in each product. You want to have one only formalism. So what you want to do is define a specification, and then all the data product should expose their data contract using that particular specification. And then you want to have a platform that is able to collect all the data contract and enforce them. That basically mean manage their life cycle, controlling that the data contract is conform with the specification, that all the parts are properly defined. This is at creation time. And then at execution and runtime, you want to continuously check that the specific data product is respecting the data contract that are exposed. So you need these two things. You need a specification, and you need a platform that is able to manage the life cycle of a data product from creation to the commissioning of the product that have defined that particular data contract. Here we have open sourced the specification that we use with our customer, and is available online on our GitHub. There is the link. I can share the link, and probably the link is also in the abstract of the meetup. And we have also released the platform, not all the platform, but just the module for the moment that implemented the registry that we use with our customer to manage the life cycle of this data contract. All these projects, specification and the platform, now the registry module, in the later part of the year, we are also going to release the deployment module that is able to basically deploy a product associated to a specific data contract are available under the Open Initiative page. We have an home page, and we have also a page on GitHub. So if you want to check the code, just to take an inspiration on how to define data contract with your organization, or to modify and customize the specification according to your need, or customizing the code of the application in order to not start completely from scratch, you can do that. And then if you want to contribute back what you have done in terms of feedback, or spread the knowledge about the existence of this project, or contributing some code, we are more than happy that collect all your kind and type of contribution on that. Is an open initiative. Everybody is welcome on board. Just to say a couple of words about the standard. The standard basically is not a standard to define only a data contract, but is a standard to define a data product in all its components. So define the interfaces, of course, but also define the application that implemented interfaces and the infrastructural component. So basically it can be seen as a descriptor, as a manifest file, then that can be then used by the platform, not only to enforce the data contract, but even to deploy the data product and manage the life cycle, not only of the interfaces of the data product, but of the data product as a whole. These are the key components. So we have a block of information that generally describe the data product, its goal, who is the owner of the data product, and a lot of other general information about the data product. Then we have a block that describe the interfaces, and then we have a block of configuration that describe internal application and infrastructure that is needed by the data product to be run in a production environment. Of course, all the part related to the description of the interfaces of this specification can be used to define your data contract. There are a lot of other specifications to describe data contract, or more wide specification like this one to describe data product. For example, recently PayPal have released the specification that they are using internally to define a data contract. So you can have a different example. You can check all of them and decide what is the better fit for your situation, and then maybe creating one from scratch, from composition, or pick one of the many that are available on the market. Here, the important thing is that aside the specification, we have also a platform that is a registry of this data contract, and we are going to release other module to automatize, completely open source, all the procedure to manage the life cycle of the data product as a whole, so also to manage the life cycle of its data contracts. Just the part of the data contract that I have defined before, so the API, the constraint, and the semantic are part of the specification of the API, especially of the output port and observability port, within the specification. I don't want to go too much into the detail, but on the website we have a tutorial that describes all the specification in part to an example, but basically it's there. It's a way to specific what is the API of the port, what are the constraints, what is the semantics. So there are all the stuff. Of course, the standard has been, the specification has been designed to be really open. So a lot of parts are optional. You can define them or not define them, and there is also possible to extend a lot of part of the specification, adding your custom properties. And last but not least, every time there is already some other specification outside that cover how to describe a part of the interface or of the data product in general, we do not reinvent the wheel, but we generally point to this external specification. So for example, if we are talking about data contract, an important part of the data contract is the specification of the API. We have not recreated within the specification how to define your API, but we have created the point to an external API definition that can be defined using different existing specification. So we can say that this port is defined using open API specification, and this is the specification of the API compliant with the open API specification, or this other port is a table described with the data store API, and this is the definition of this specific API. This is true for the API. This is true for how we define slow and SLA. For example, we use open slow. So we are really open to reuse also the specification that are available outside. Also because when you use and reuse a specification that already exists, you also are able to leverage all the tools that that specific community have already implemented to manage that particular part of the configuration. Then, as I said, we have released the platform. The platform is modeled on the architecture that I have described before for a data mesh platform. It's composed by, there is not, it's an headless platform, so there is not the mesh control plane. There is only the utility plane and the data product plane. The data product plane specifically receive the data product descriptor that contain also the part that describe the interface of the data contract, save them into the registry. That is the first module that we have released. We are going to release other modules, for example, to give grant and access grant to the data product, to manage the deployment of the data product will be released later on this year. For the moment, there is only the registry. And the utility plane instead allow the data product plane to talk with external application in a decoupled way. So without calling directly the specific application, but calling an abstract interface that is common. And then this interface can be implemented with different adapters that call different applications. So the data product plane can be moved in a different ecosystem that use different applications. For example, for data catalog, for policy checking engine, you can have your product already in place. You just implement the different adapter of these interfaces exposed by the utility plane, and you can inject and plug in into the platform this application and can be orchestrated by the product plane. Last three slides, I think, and then I'm over because I've already talked for more than an hour. How the registry module work and how it help to enforce data contract. Basically, in the platform, the idea is that you define your data product, and so the data contract that describes the interfaces exposed by the product using a GitOps approach. So you define your specification, the description of your data product, your data contracts on Git. Then when you merge your contract with the main version, or when you create a tag, or when you create an event that is used to specify that a new version of the data product descriptor, and so as of the data contracts related to that data product has been released, this is tracked. So I have a Git hook or a GitHub action, whatever you prefer. And the contract is the data product descriptor and all its contract is published on the registry. The registry do different validation steps. So first of all, there is a technical operation, reduce all the reference, because the description of the data product can be a very large document in YAML or JSON. So to simplify the management of this descriptor file, it's possible to referentiate an external file. So maybe you have one file that is the root entity of the descriptor, and then you have a pointer to the different API, pointer to the different application, pointer to the description of the different platform components. So the first thing is a technical operation is to dereferentiate the file, and so create only one file with all the information and merge all the different files that compose the descriptor. Then there is a syntactic validation. So we do a check to see that the descriptor file is formally correct, respect the specification. The specification have an associated JSON schema, so we can validate the schema of the specification provided. And then there is a compatibility validation. So compatibility validation means that we check that the new version is backward compatible with the previous one. And if not, we raise an event that can be notified. And by this notification, the publication can be refused or not, depending on the policy on a breaking change in the data product description. So basically, we perform this operation, extracting the schema that are exposed by the different port, and do a compatibility check with the schema exposed by the same product in the previous version. information. And if there is a breaking change, for example, I have removed a column from a table, I have changed a type in a specific field of a message on a Kafka topic, I can say, okay, here there is an incompatibility between the previous schema, and so with the previous data product interface, what you want to do. You want to stop the publication or you want to go on, depends. And if this phase is passed, then there is a compliance validation. Compliance validation is really, really important, and is what makes the registry also so useful also in this stage of development. Basically, we call an external policy engine in order to validate the semantic content of the contract with the global policy defined by the central governance team. So, for example, the central governance team can specify that an output port can also be exposed with a REST service, but this must be defined using OpenAPI specification, and this must have only endpoint in GET, and all the schema of this endpoint must be represented using protobuf. So these are a set of policies that can be expressed as a code and checked by an external policy engine to validate the compliance of the descriptor file and the data contract contained within the descriptor file. Here, as you can see, this engine is not implemented within the registry, but this is just an interface provided by the utility plane, standard interface provided by the utility plane that is called by the registry. And then behind this interface, you can plug in your implementation, your adapter implementation that implemented the interfacing, calling the solution that you want to use as a policy engine. We have at the moment implemented an adapter toward Open Policy Agent that is a quite popular open source policy engine. Last but not least, another important thing before the final registration is the propagation of the metadata contained into the descriptor file, especially in its API, to other external applications. Usually we publish, for example, all the metadata related to the exposed data, their schema, their API, into the company data catalog. So basically, there is a notification that, okay, I have a new data product descriptor that is okay, it's compliant, it's static valid, and all the observers that are attached to the registry are notified, and these observers are general interfaces that can be implemented with different adapters. At the moment, we have created an adapter for a governance catalog that is named Blink Data, but you can create your adapter for Data Hub, for Colibra, for whatever you want. So all the system downstream that whenever a new data contract is created, a new data product descriptor that contains a set of different data contract is created and is valid, can be notified and can extract the metadata information contained into the descriptor and do whatever they want. Usually these are data catalog, but can be also, for example, another useful implementation that can be provided in the future is an adapter that receives this notification and create the schema on the schema registry of Kafka related to an async API exposed by a data product. So you can also use the registry not only as a registry, but also as an hub that propagates the information about the data contract to external application. In the future, what we want to do is also to create, implement, and basically we have already something for our internal project, but we want to release it in the future, maybe not this year because we are focusing more on the deployment module, so that is able to take the descriptor file and create a running instance in production of the data product. But in the future, we can also create and release an observability module. The observability module basically enforce the contract at runtime. How this is performed. Here is a general schema of how this could work. Basically, as I said, into the data contract, I have defined the schema, and probably I've defined also some constraint that specify what is expected to the data that apply to that particular schema. So what I can do to monitor and enforce this data content at runtime is to have a model of the platform that periodically call the output port, check the data generated by the data product, and do some quality check to verify that this data is compliant to the constraint, is compliant with the schema declared, and if not, arise an exception, and this exception generate an event, and an event can handle in a different way. For example, the consumer of the product can be notified that the product have not passed all the quality tests, so is not compliant with his, at this moment, is not compliant with his contract, and so the consumer can face some problem or data downtime. On the other side, another possible thing that the monitoring observability module can do to enforce contract is to check the observability port to get data related to service level indicator. So, for example, the availability of the data product, the uptime of the data product, the last time that the data product ever refreshed the data exposed, and use all these service level indicator to calculate the SLO and SLA that are defined into the data content and verify that the threshold is met. Otherwise, if they are not matched with the threshold of the SLA and SLA declared in the content, the same. An exception can be raised that generate a notification, and but this notification can generate a different type of action by the observer that are interested in monitor the service level performance of the data product. Last but not least, this module can collect all this historical data about how good the data product is able to keep its promises and to respect the content that it exposes, and calculate a sort of trust score, that is how trustworthy is this data product, how this data product is good to respect its contract. And this can be an indicator that can be used by potential consumer to decide if that data product and the data exposed by that data product are sufficient trustworthy to be consumed for the use case or not, or if not, they can go to take another product and look out for another product that exposes similar data, or try also to extract their data from themselves. So this is also important to promote the data product that are, think, for example, at the mesh control plane level, when you do a search, to promote more data products that are more trustworthy, that have a better value for this trust score calculated on the previous and past performances, and instead push down products that are very not good in keeping their promises. Last, these are all related by technological part. I take the last 7 minutes or less, I hope, to instead focus a little bit more on the organizational part. As I said, the organizational part is the more complex one, especially when you want to push the data contract concept on the operational world, because within the team that work with data, it's something that can be more easy to be implemented because they see directly the advantage of that. Instead, when you are asking to an operational team, a team that work with an IRP application or another application that implement some business process, this is not a responsibility that they usually have. Usually, when you need to extract the data from an operational system, the operational team say, there's no problem, this is my database, you can access to the database, take whatever data you want, I don't care, but I have not any kind of ownership and responsibility. So if tomorrow I change the data, your pipeline break, but I don't care. I even don't remember that you have access to that particular data. If you are trying to push the data content and say, okay, now we define a data content, you don't give me the access to all the database, but I need to have these two tables, define a data content, define the schema, and respecting the schema is your responsibility, mean that it's your work, mean that you have to spend part of the budget or your budget operational team to enforce this content, keep this content valid, is something that they are not want to do. they don't want to do, at least if there is not a clear push from the higher. So if you have not a sponsorship that are able to change the operating model, create incentives to this team to perform also this work that is an extra work for them. So you have to create the right incentives in order to make possible that they will do that, even if in a stressful situation when they are pushed to release new functionality, and not only in the best situation in which this can be performed in the best effort. So this is a possible journey. I want to go very fast on that, but basically the idea is to start really small in the adoption of data contract, maybe start implementing them within one team, within the data team. If you have a central data team, modularize your application, create data contract, start to create a minimum viable platform to enforce the data contract. If possible, do not start from scratch. Look at what exists already outside and contribute to different projects, or just take inspiration from what is existing out there, because a lot of error has been made, and so give a look to what already exists out there can save you to do and repeat some error that someone else have already done, and find a solution. But create this specification, your own specification, create your minimum platform to enforce the contract, and start to run the contract within one team. Collect the data that you produce using data contract in order to prove the saving that data contract allow you to enable in terms of better data quality, reduce the number of error, reduce the time of data downtime. So collect some number that can be used then to produce a business case to propose to your sponsor, in order to convince it to change a little bit the organizational model and push the adoption of data contract also to other teams, possible more close as possible to the team that generate or consume the data. Do not try to be bulimic, put everything in the contract. It's nice at the beginning, you want to do everything, data quality, schema, API, constraints, semantic. Data contract must be sustainable in the long run. So it's more related to the process than to ideal and best possible data contract ever. It's better to have something less that is sustainable in the long run than having things that you are not able to sustain in the long run, and so require effort to be defined, but no one try to really enforce. So use in the escalation and diffusion of the data contract, if you find a sponsor that believe in your business case, go very incrementally in the adoption. Add only the part to the contract that you are sure that you can implement, and all the team that have to adopt data contract can effectively implement, and you can also enforce in automatic way using the platform. And between the different possibility things that you can add and provide value to the data contract, select always and prioritize according to the expected value, to the expecting impact that the data functionality have on your case. So if your main problem is data quality, maybe the next feature that you want to add to a data contract is something more complex in terms of constraint. If your problem is lineage, maybe you want to add something that improves the lineage between the different products. If your problem is searchability, because it's not clear how different products are correlated or what is the meaning of the field within the schema, maybe add something related to semantic and the correlation, create the correlation to semantic linking between your schema and your business glossary. So do all these hypotheses of value to prioritize the different possible things that you can put in your data contract, and do not try to over adopting it. So do a very experimental way and move step by step, because it's very easy to add to a specification the fact that you have to add to the contract this, and that. It's very difficult then to implement and to keep it constantly updated and valid for all the data products. So do small modification, try to test, and every time decide the next modification in terms of the aspect that is more important for you and can create more impact and more value for your organization. So that it's over from my side. I take 1 hour and a half as promised. I hope that you are still alive after that.